Morning everybody. It's Sunday morning and I'm just going to try to get one quick video out, hopefully give you something exciting today. Alright. Well, today we're going to be talking about the cooling and mounting of stud mount and hockey puck type SCRs and diodes. So for those of you following along at home, that's going to be chapter 17 in the SCR manual. I've got the 4th edition, so yours may be a little bit different. But what we're going to be considering today is, do you need any heatsink compound on these stud mounts? And this is where we're going to be focusing most of our time today. Now for this type of diode, we're probably going to be looking at a little more than 5 watts. So we maybe we're going to have to consider some of these calculations here. I'm kidding, of course. I think I just lost 2 of my 12 subscribers. Today we're going to start off with probably the most important part of the decompression table, the pilot regulator. This is what's actually going to be maintaining force on my body. So regardless of how I actually control this force, that's up in the air, and regardless of how I apply this force to my body, that's up in the air. But one thing I do know is I'm going to need something stable and accurate if I want this to provide a good solid force on my body. So I'm going to start out with this Fairchild because it looks the best. I do have a second Parker pilot regulator, which I would like to get working, but it's I don't know. I like Fairchild at this point. I've just kind of a loyal fan in their aviation stuff, so I'm going to start with the Fairchild just because of that. Nothing against Parker. They make good product, but we'll start with Fairchild and see where it goes. So something I was afraid of when I bought all this stuff is I don't know where it came from. When you're buying used equipment, especially industrial equipment online, you have no idea if it's been used in a hospital or a nuclear power plant or sewage treatment plant. If you're lucky, it's been sitting on some guy's shelf collecting dust, but sometimes you get them in and they've got, who knows, hydrazine or something in there. So I did get a radiation meter. It is technically a Geiger counter, I guess. My last one wasn't. It was just like a survey meter. But this one does show that there is no radiation in any of these components, so that's good. I can safely sleep at night knowing that it may have some sewage in it, but at least it doesn't have gamma particles shooting out at me. So that's reassuring. So I went through all of my buckets and baskets and conjured up just about every fitting I could find. And it all basically fits into this one box, and this is the best that I can do. One fitting, and it's a bar bend. So I'm gonna at least start on it. Probably put a hose on it, one of these old rubber fitting hoses, and just clamp it on there, and something tighter than that. But just get cracking on this, and of course I'll be ordering more fittings and junk as I go along the way. Eventually I'm sure I'll have a nice collection of pneumatics, but for now it's going to be a little bit tricky because I just don't have any of that stuff yet. I thought this is pretty cool. I think I'm on the right path. So I had just bought these just off of a whim. I had never dealt with pressure stuff before, so I just went online and looked what was convenient and readily available. But here on this one, which came from industry, they've actually got, it's brass, but they've got a push fit right angle 1/4 MPT adapter. So look at that. I actually may know what I'm doing after all. So this, I know, is not recommended. It's just standard old, what is it, nylon tubing, polyethylene, some sort of plastic tubing, but it's not reinforced. I'm sure it's not rated for, I don't know, 20 PSI maybe? I really don't know. But I'm not going to run it much. I'll keep it all regulated real down low so I don't go popping anything. And if I do, it's probably not the first thing that's going to happen on this project that's bad. I am eventually going to be building something that's going to stretch my spine out, so yeah, we'll see. Alright, moment of truth. We're going to hook up the air supply, see what happens. So hoping this is all sitting still, there should be no leaks. So as I crank the pressure up, I would expect nothing to come out. So let's give it, my tubing has a little leak, but no big surprise there. Oh, that's 40. There we go, 20 psi. And I'm leaking from the regulator. So this regulator is a kind of a piece of junk, so I'm not too worried about it. Hey, look at that, beautiful. All right, so regulator's good. I got 20 psi and I have absolutely nothing at the output, so that's good. At least it's holding pressure. Now what? I got to get pressure into there. So I got a needle valve here, and I need something to get air into there, so I'll need to split the supply. So let's see what happens here. I've got a little needle valve here going into a tank, and then I've got this one on the main line. So oh, hey. Look at that. So now I crank the needle valve up. Probably need some like closed loop on this. Like I probably got to put you know, just run an open circuit. So I'll put something on the output of this, and I'll put some gauges on it so I can see what the heck's going on. And yeah, I'll let this compressor run and turn off, and back in a second. Fabric hobbled. I believe that's the word that AVE would use, and that's what I would use in this scenario. I've got an old, I think it's 1/2 inch MPT, I don't really know, but the only fitting I have is an old ice maker one with compression fittings. But I don't have any solid copper tubing. I used all that on a Tesla coil, and I don't have any of the rigid tubing, so I'm going to use vinyl, which obviously this is not meant to be. But what if I shove a piece of sprinkler tubing in here, kind of fatten it up, and cut it? You know, this is definitely quality stuff here. I would never do this for something going into a proper installation, but just for tinkering, who knows, maybe it'll work. Crimp down on that. Heh, probably not going to hold. Try one more time with more tubing, and then yeah, we'll see what happens. This may or may not be a smart idea. It probably won't work, but you know, again, we're only running at 20 psi, and what's the worst that could happen? Blow my ears out? I got my ear protectors on here somewhere, so yeah, hopefully. I don't know if those will actually protect against a pressure burst, but one way to find out. It's a moment of truth. So I have got this contraption. I'm going to turn it on, and this is by all means the weakest link. The vinyl tubing with the compression collar just crimped into it, so if anything's going to give way, I think that's going to be it. Alright, so we got a piston. I'm giving it 25 psi at the input. And then here at the reference port, I've got like, how am I? Okay, there's some leak by. I need to get this camera closer. So I should probably take a step back and explain what I'm actually doing here. I've got, on this line right here, I've got just one of those, you know, car air tanks, just a portable one, filled up to about 70 psi. Got a needle valve, pressure gauge, and this goes into the pilot port. So we'd really expect there to be essentially no flow, maybe a little bit of leakage because my fittings and all, and maybe some internal leakage in here, but there really shouldn't be any flow there. This is my pressure line coming from the compressor, so this is the high flow line. I've got it regulated here right now. I'm sitting at 0. Goes input, output, monitoring it on a pressure gauge, and I've just got a test cylinder here. So this thing has a pretty big spring in it. It's a spring return. I was just buying it for proof of concept, so I'm hoping that this will try to maintain a constant force based on what this needle valve does. So I don't want to crank it up too high because it'll probably bust this tube. But I'll go ahead and put my earphones on anyway just so I don't pop an eardrum. So I'll crank it up to, I know this tubing's rated for 20, so let's just double it and go to 40 because that's how engineering really works. Yeah, that looks fine. So we got 40 psi at the input, 0 at the reference, and our pressure, piston is doing nothing. So cranking it up, and you can see the output start to rise. I've got it at 10 here, it's 10 here, and that's actually pretty much what I was hoping, was it would maintain a constant force, and it does. I mean, it's hard to see on video, but as I'm pushing here, it feels essentially it feels about the same. So as I'm pushing down, it's going to bleed the pressure off from the regulator. And this is important because if you're on a table and this is decompressing your back and the harnesses are flexing, you'd want the piston to keep that force constant and take up all the slack. I'm not as worried about the other side of it. You know, it's going to be pulling against my back. I'm not as worried if I push into it. I'm more worried about as it slips that it'll take it up and maintain that force. So let's go a little higher. So go to 20 here. Cool. So it's got, yeah, 20. I don't know what the surface area is on this, so I don't know what kind of force it's putting out. So let's see if I can, if I shove it in, you would expect the pressure gauge to go up and then drop back down. Probably not going to be able to see it, but you can kind of see it. So as I push in, the needle jumps a little bit, and then as I let go, it drops a little bit. If you go higher, maybe it'll be a little easier to see. I can't go higher than 40 because that's what my supply's at, and I don't want all this to blow up in my face. Huh. Yeah, I mean, it's hard to see, but what's interesting and what works for me is this is a constant force. So as I push on this, it stays constant. So like, you know, that feels the same as that does. As you push it in, it lets the pressure out. So it's not like it's getting harder to push in. It's staying the same force. Being a spring return, that's probably throwing some of this stuff for a loop because of pneumatics and whatnot. But this seems to work. I mean, the regulator seems to be working just fine. It's, you know, forget the piston for a minute. If you just watch the input and output gauges, as I drop this one, it stops the airflow. And as I slowly crank the needle valve up, it'll match. Let's go all the way. Yep. So I'm over at 60 psi on the reference port, and it's only putting out whatever the supply is. In this case, about 35 and dropping. I really want to crank it up higher, but I don't want this tube to pop on me because I mean, talk about using something absolutely not as intended. This, you can see that collar is just going to cut right into that nylon tubing. It is not designed for it. So I've just got a compression collar in there. It's just going to shear that tubing and cut it right in half. So I don't really want to crank it up until I get some proper fittings on it. But yeah, good. So I'll also try the Parker. So the Fairchild works out of the box. I don't see any reason to jack with it further. I'll leave it be because it's working, and then if it dies, I've got a backup rebuild kit. And then the Parker, I'll give that one a shot. Because eventually, once I don't have the fittings for this yet. These are some super tiny little bitty things. Once I get the fittings for this, these are what I'm going to eventually be using, and they are not spring return. So they're air inflate, air to deflate. So I'm hoping, and I've got 3 of them, so 6 pistons total. So that, I assume that'll be fine. I mean, it's one thing for the regulator to control this little air volume, but doing a bigger air volume, I don't think it'll be a problem. That's what it's designed for. So cool. Well, I'm happy. This at least gives me hope that I'm on the right track. I was worried that this that this was going to be just totally useless. Alright, well I'm going to switch it out to the Parker regulator. Well, the good news is the Parker has all quarter-inch PT, so I can actually crank this thing up all the way. It has a couple of gauge plugs in there for, you know, monitoring the output, so I got to plug these. So I will get this all plugged up and plumbed up, and we should actually be able to crank this one to full pressure, because everything here will be rated for my supply air. Well, I hadn't intended to take this thing apart. I was wrenching down on the pilot port, and the whole cap turned, so it's just finger tight, which either means A, it wasn't put on right at the factory, doubtful, or B, someone's been in here.
Daddy, I need something out of Mama's car.
What do you need out of her car?
Goes to the back, so I'm gonna go get your car keys in.
Sounds good.
Come with me.
Yeah, I'll get it.
Open the garage door right now, please.
In a second. So, looks like it just has a pilot diaphragm, pushes on a coupling which has a hole in it, I assume to let air escape. Yeah, there's a hole drilled in the side here too, so I guess that lets air escape in here. Man, these diaphragms, these aren't rubber, these are some sort of nylon or injected plastic. I can see injection marks on it.
Now, can you come?
Number 2. Yeah, let's go. Hold on, duty calls. We're back. So this, I assume, pushes on. Yep, there's a spring button there, which probably pushes on the bottom diaphragm, just like a traditional regulator. My hands are all dirty, so I shouldn't be working on this, but it'll be fine. So yeah, makes sense. Just like your normal standard run-of-the-mill regulator, but instead of, you know, a T-handle, it's got a pressure chamber that pushes down on it. I don't know why it would have that hole in there for the air. I guess if any air leaks from here into here, you wouldn't want that to leak into here and cause bad reading. So if you have any blow-by here, it would come out of that hole, and vice versa. Any blow-by here would come out of that hole and wouldn't affect the actual pressure, maybe? I don't know. Like I said, I'm new to pneumatics. Reference pressure, and beautiful, just beautiful. Here's no, I mean, this is just proof of concept. It doesn't have to be pretty, right? Right. One more here. And these push fit fittings and tubing, it's really cool. It's like Lego blocks for pressure, and I don't remember what pressure it's rated for. I think it was like 300, but it was enough. Alright, so we got 70 in the reference tank and plenty in the main tank. So I'm just going to crank this thing up to, let's go to 80 psi on the input. Oh, you know what? This is a 1 to 6. Let's back that back down, because I don't think that this is rated for that much. So let's go to, well, no, we need a lot on the pressure side. We don't need a lot on the input side. So yeah. Yeah, 80 it is. 80 psi input. We have no leaks here, and 0 here, 0 here. Oh, I'm not hooked up. This. Pressure here. working. Got a little leaky, but it's working. There we go. It makes it a little easier to... Where am I leaking from? Okay. More leaking. Oop, pinch the line. Yeah, it's that fitting right there. I was using the default factory Teflon they had on there, but it wasn't that good. I hear crying. Alright, let's see how quickly I can get this done before they come out here. So, look at this. This is much better now. I don't know why it's easier to see on this one. So, we got 30 there. I push in, it goes back to 30. I let out, it goes back to 30. But this is... It looks like a 1-to-1, but it looks like it's got some negative bias in it, because I've got 32 input and 28 output. And I do remember reading about that there was some bias adjustment on these to give it an offset, which for my purposes I don't really need, but I can certainly look at trying to get that adjusted. But I thought this was a 1-to-6. I don't remember why I thought that, but it's not. It's just a 1-to-1, so that's fine. That'll work. That's why I got 6 of those pistons anyway, because I didn't know how much pressure I was going to be able to control here, and because these guys here are what I'm going to be controlling the pilot port with. That's right, that's right. This one, that's right, now I remember. I bought this one, the 2 to 90 output, so that I could get, with a 1-to-1 pilot regulator, up to 90 psi out, which should be enough. This one, this is the far more common variant, is a 3 to 15. So all I'd be able to get out here is 15, which, even with those 6 pistons, I don't know if that's going to be enough to wrench on the back. So that'll come later. I mean, at this point, it's still all just proof of concept. I didn't want to go blowing a bunch of money on stuff if it wasn't even going to work. But, you know, I think we're onto something here. I do have a leak here. Where is it? Oh, it's in the... Yeah, I may try to get this all sealed up. Just so I can do some better testing. But that's pretty cool, actually. Oh, now I got the... No, it's not jammed. Oh, that's cool. So when I push down on it real hard, you could hear it come out of the... Let me see if I get the mic on that. Sorry about the noise. Alright, cool. So when I push on the piston, it'll vent out of the pilot regulator vented it. So the pressure built up in here will get vented out of here. It's self-relieving. So that's cool. Alright, well that does everything that I wanted to do this morning. It works. Both of my pilot regulators work. I don't even need the rebuild kit. And as far as the next steps, I think next will be getting those current to pressure transducers working. So that'll be the next video, is essentially, you know, this is one block, the pilot regulator. This is the next block, the control side of it. You know, needle valve is fine for proof of concept, but on the actual table, I'll be mocking it up with something like this just for electrical proof of concept. If I can get this 4 to 20 milliamp controller to work, to control the whole thing, Well, then I can throw an Arduino in there and do whatever software, programming, curves, ramps, all that good stuff. You know, that's easy as long as I can get this electrical interface to work. So that'll be the next block, is the current to pressure transducer. And then I'll probably work on the pistons and do some force calculations and see, you know, what it actually is going to take to get that target of half of my body weight for pressure. Cool. Well, that's exciting. Alright, well, I hope this video was exciting for everybody. There's going to be many more equally as exciting. You know, eventually we'll get to welding and whatnot, and we'll see how good I am at that. I'm about as good at welding as I am with pneumatics, so you'll probably see some more of this style stuff, you know. Compression fittings on vinyl tube. What could possibly go wrong?